Oh boy, do I have a video for you. It's the binomial distribution. This is the last section of this here chapter, and by golly, we only have one chapter after this. So your essential question today is, how do I calculate the probability of a series of probabilities that can happen a couple of different orders? So here's your essential meme of the day. I love Gandalf. Gandalf. Consider. You're flipping a coin 4 times in a row. What is the probability of getting 4 tails in a row? All right, I'll stop the accent, but I thought it was pretty good while it lasted. I think that was sort of a Minnesota/northern accent. Anyway, getting into it, here's the deal. We're flipping a coin 4 times in a row. Now, we've looked at this sort of problem before. How can you calculate the probability of getting 4 tails in a row? This is easy. Set up 4 slots. This guy has to be a tail, this guy has to be a tail, this guy has to be a tail. 1/2 times 1/2 times 1/2 times 1/2 equals 1/16. So easy. But the problem gets a lot more complicated if I'm looking at something like this. What about the probability of getting 2 tails out of the 4? Now, first of all, let's think about this. Is it very likely to roll or to flip 4 tails in a row? No, it's not. That's why it's only a 1 out of 16 chance. But getting 2 tails out of the 4, that seems like it should be a lot more likely, right? 2 tails, 2 heads, 50% chance. It seems like this should be more likely. But if I try to use slots, let's look at what happens. I'm definitely going to have 4 slots. And how do I know which one's a tail? Because it's not saying tail, then head, then head. It's just saying total, you need 2 tails. So is this first one a tail? I don't know. Is this next one a tail? I don't know. And because I don't know, even if I do 1/2 times 1/2 times 1/2 times 1/2, and that should make sense because like heads and tails are equally likely, don't I have many different ways that this can happen in? So basically it's more complicated than just doing 1/2 times 1/2 times 1/2 times 1/2. I need to figure out how many different orders this can happen. So it's kind of like putting a counting problem and a probability problem together. Here for 4 tails in a row, that can only happen one way, right? But here 2 tails out of 4, let's look at it. I could have tail, tail, head, head. I could have tail, head, tail, head. I could have tail, head, head, tail. There are so many different ways. And however many ways there are, I'm going to need to multiply my probability times that many ways. So here's what mathematicians figured out. I have 4 slots. I need to choose 2 of them for my tails. If I multiply these slots by this combination, that will give me all of the different ways that this can happen, okay? So, 4 choosing 2, our calculator can do that for me. I think it happens to be 6. So the problem actually is going to work out being 1/2 times 1/2 times 1/2 times 1/2 times 6. And that equals 6 out of 16. So this is 6 more times more likely than this, which feels right. It feels like you should get more tails than heads. This, by the way, reduces to 3 out of 8. Almost 50% of the time, I'm getting 2 tails out of the 4. Interesting. Now, if this is a little confusing to you, I understand. We're getting into a very specific application of some probability things. I'm going to do another example, and then I'm going to teach you a formula you can use if you want to. So here's our next example. You're rolling a die 10 times. What is the probability of rolling 3 6s? So let's think about what's going on here. Since I'm rolling the die 10 times, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slots. And I'm looking at the probability of rolling 3 6s. Now, clearly there's a 1/6 probability of rolling a 6. But where do I put that 1/6? Is it happening first? Is it happening fourth? Is it happening last? I don't know. I don't know where to put the 6's. And so in order to figure out all the different possible combinations of places I could put the 6's, I need to multiply this probability times 10 for the 10 slots, choosing 3, because it's choosing where to put the 6's. Interesting. Now, here's the other issue. I know that 3 of these slots need to have 6's in them. And I'll just put them in the first 3 because this combination is going to take care of all the other different possibilities for where I could put them. But what's going to happen in the other 7 slots? Well, if these 3 slots are 6's, these other slots are like not 6's, right? If I'm only rolling 3 6's, all of these other ones have to be not 6's. In other words, I need a 1, a 2, a 3, a 4, or a 5 in all of these other slots. In other words, 5 out of 6 for all of these other slots. Now, you can shorten it, and the shortening should make a lot of sense. 1/6 to the third, right? Because there's a 1/6 in 3 of the slots. 5/6 in the other 7 slots, and then times 10, choosing 3. And I'll do that in my calculator as I tell you one more thing that you can think about in these problems. That 1/6 and 5/6, aren't these complements, right? These are complements, meaning they add up to 1, right? Because here are the 6's. Here is everything else for each of them. So this 1 out of 6 and this 5 out of 6 are complements. So I'm almost done calculating this. 10, choosing 3. The probability is 0.155. So around like 16 or 15%. Interesting. Now, if this is all confusing, thinking about it kind of intuitively like this, I want to give you a formula that you can use. So here's the formula. If you want to calculate a binomial probability, here's the formula. P to the n times q to the, P to the x times q to the n minus x times n combination x. Now, here's what all these variables mean. Let's look back at the last problem. P, that's the probability of like doing what they want you to do. So I'm going to call P the probability of success. Probability of success. What's the Q? Well, let's look back at this previous problem. If the probability of success was 1 out of 6, that's the probability of rolling a 6, the probability of not rolling a 6 was 5 out of 6. So the Q, I'm just going to say, is the complement of P. If P is what you want, then in all of the other slots, Q is what you don't want. So what's the N and the X? Well, N, that would be this one. That was the total slots, right? The total times it's happening. The total slots, or the total times it's happening. X is going to represent the number of successes. So in the last problem, let's just kind of analyze this formula with the last problem. The last problem, I wanted to know how many times out of 10. So 10 was my n. And I wanted 3 out of those 10s to be a 6. So x was 3. Since I was rolling a 6, P was 1/6, and Q, the complement, was 5 out of 6. And if I plug all this stuff in, 1/6 to the 3, 5/6 to the 10 minus 3, 10, choosing 3. The only thing I have to simplify is here. It simplifies to 7. And that makes a lot of sense because 3 slots have 6's, 7 slots don't have 6's. All right, I'll cut the video off there. A binomial distribution, it's when you're doing something multiple times in a row, but you're not really caring about what order they happen in. So like I'm flipping 2 tails, wherever, or I'm rolling 3 6's, wherever. There is a formula. I gave that on the last slide, but it's probably easier just to think about it, or at least that's what I do. Hey guys, we're going to practice this more in class, and I'll try to answer your questions because I know this is a pretty tricky concept. So, thanks for watching.